Um, so I thought I would make a video talking about math because, can't really wait till I actually get the supplies. So I thought I would talk about the very basics, going back to algebra. And what I want to talk about are functions. Specifically, what are functions? Functions are basically just rules. But functions have a particular rule. So for a function, you are given inputs. These inputs could be anything. I'm not going to get into the specifics what the inputs are going to be. They can be numbers, they can be vectors, they can be tensors. Don't worry if you don't know what vectors and tensors are, that's fine. But for the most part in algebra, you'll deal with numbers. So your inputs will be numbers. Your outputs will also be numbers. So you're given a set of inputs, and for each input, you only get one output. That's basically the rule for a function, right? You can't have one input giving you two different outputs. That's not what we call well-defined. So that's basically what a function is. So a very simple example of a function that you'll encounter in algebra is just the one where each input that you give gives you the exact same output. So that particular function is written as y is equal to x. That's just a straight line through the origin. So if you put in the number 1 for your input, you're going to get 1 as the output. Simple as that. If you put 2 in, you get 2 as your output. So on and so forth. Now there are different types of functions. There are what are called even functions. So for even functions, if you switch the sign of the input, so in this case if you go from a list of positive numbers to a list of negative numbers, the function doesn't change. So basically the output doesn't change. So whatever rule you've applied to these changes, it doesn't change overall what you get out. Now an odd function is not the case. An odd function, if you switch the sign of the input, you are going to switch the sign of the output. So the function itself will basically change. So for an odd function, if you were to switch the sign of the input, that function will be equal to the negative of your original function. So let's say, for example, you had the function x cubed. X just being any random number that you can throw in. I should also specify that x is just a random variable that we've chosen. Now, what is a variable? It's just an assignment that we give to, in this case, numbers that we haven't specified. So x can be any number that you choose, okay? So if you were to throw in the value, let's say if you chose y is equal to x cubed, and you threw the value 1 in, well, the value of x is equal to 1, and you cube that, that's just 1. Now what happens if you change the sign of that? So what happens if you throw in, instead of 1 into your function, you throw in negative 1? Well, you get negative 1 times negative 1 times negative 1, because that's negative 1 cubed. So in that case, you just get negative 1, or you get the negative of the original function. So that's what an odd function is. Now, why do we even care about even and odd functions? Well, whenever you move on to calculus and you integrate functions over certain intervals, let's say you integrate a function around the origin. You don't need to know what integration is, that's fine. But let's say you're looking at some function that is centered at the origin. If you were to integrate a odd function, well, your integral would be 0. So like an example would be y is equal to x cubed. That's centered at the origin, and it basically just looks like basically 2 half u's, so like one upside down u and then one right side up u, sewn together at the origin. That is an odd function. If you integrate that, on either side of the origin, you get 0. So you don't even have to do all the work of doing an integral. For example, if you have another function like y is equal to x cubed. So y is equal to x cubed, what that function is telling you is whatever input that you're given, in this case x, you're just multiplying it by itself. because that's what x squared is. It's x times x. So if you were to integrate that function, centered at the origin, because y is equal to x cubed is centered at the origin. When I say centered, by the way, I mean symmetric. In the case of odd functions, it's not quite symmetric. I'll talk about that later. But if you were to integrate that parabola, or that equation y is equal to x squared, you would actually end up getting an answer. So you would have to do that integral, but instead of doing that full integral, you could just split it up into two pieces. You could split it up into, a piece on either side of the origin and just figure out what is that piece and just double it. Now granted, if this doesn't make sense to you right now, that's fine. This is stuff that you'll encounter in calculus. But even in odd functions, definitely play a role later on when you get to more advanced math, because that'll actually tell you if you need to do any work at all. It saves you work. Now, the common functions that you'll encounter in algebra are linear functions or linear equations. And you've probably seen this before in your textbooks. Y is equal to mx plus b. That is just the equation for a line. You have your input, which is x. This input's multiplied by some number, which is m. And you just add an arbitrary number. That's the most general way of creating a line. You're kind of throwing in all possibilities. You're throwing in the possibility of shifting your function. You are throwing in the possibility of stretching your function, which is what the number m does. The shift is whatever constant you're adding. So y is equal to mx plus b, your shift is b. Your stretching factor is m, the slope. And really that's it. And you can extend that definition to quadratic functions, except for now you're just going to have another term, which is, in this case, usually most textbooks write this as y is equal to a times x squared plus b times x plus c. C is just your shift, or your constant. B times x, that's your linear term. So you can think of basically taking the equation for your line and just adding on another term. In this case, a term that's squared. So those are the two general functions you'll encounter. Now, I won't talk about it now, but I'll talk about it later, how you solve these functions. What do I mean by solve? I mean, you want to figure out when these functions equal 0. And I think I stated before in a previous video, like for example, finding the zeros for a parabola, or in other words, where your equation for a parabola intersects the x-axis, that would give you, that in this case, those are the roots of your equation. So like when you deal with physics, you deal with projectile motion, which is parabolic motion. You want to know, okay, well, I know where I start to throw an object up into the air. It's going to go up, it's going to form a parabolic arc, and it's going to hit the ground at some later time. What is that other zero? So in this case, you have a parabola. The first zero is your starting position, where you are, where you're going to throw the ball. Your ending position is where the ball lands. That's the other zero. So like this is why we want to figure out when certain functions are zero, because it does apply to other fields, like physics in this case. At least that's what I know, because that's my major. I didn't major in anything else. Well, besides astronomy, but that's a different story. So anyway, I'm rambling on, but the main takeaway here is know that a function is a rule. It is a rule that states that for only one input, you get one output. There are no exceptions to that. There are two main types of functions that you should be concerned with. Even functions and odd functions. Even functions are functions where if you change the sign of the input, the output, in this case, doesn't change at all. So you get your original function back. For an odd function, if you change the sign of your input, your output will change sign. So that will be the negative of your original function. And again, I can always go back and make another video writing everything out, but I just wanted to make a video talking about this now. Now there are other types of functions I should mention, you know, bijective, surjective, injective functions. I'm not going to talk about that in this video. I'll talk about it in some other video. But yeah, this has been a slightly intoxicated math talk. I don't have anything to write on. I mean, I could write on paper, but then I would have to tilt this camera down and face a piece of paper, and I wouldn't know exactly, you know, how long the video is going on for, or if it's capturing everything. So I still have a lot of work to do to making better videos. So anyway, I at least hope you got something out of it. Anyway, I'm gonna go watch some Better Call Saul, and I'll talk to you later. Bye.